Okay, so anions. Now we are looking at the non-metal atoms. We're looking at the guys on the right-hand side, just before the noble gases. And we are gaining electrons to fill its valence shell. We're not getting rid of, we're gaining. When you gain a negative charge, like an electron, it becomes more negative. So for each electron we gain, it results in the negative charge being greater. If we gain 2, -2. If we gain 3, -3. You may go. You could, yeah, you can leave however you wish. Just be careful, don't fall over. Non-metal atoms tend to gain electrons. The way I remember, again, for my view, I look at the N in anion and I think negative. So that's kind of my little trick that I've always used. And you guys are looking ahead and you're already drawing, and I'm gonna, yeah, I'm not gonna write nearly that much. Okay, so let's do an example, and let's do fluorine. And I am going to start with the Bohr diagram. So I'm going to start with a Bohr diagram. And fluorine atom, how many protons in that nucleus? Fluorine, protons in the nucleus. Yep. 9, plus 9. And then you go ahead with the electron configuration. 2 and 7. All right. Again, we do a little accounting. The number of protons is 9, so we've got 9 positive, right? Number of electrons, 9 negative. We add that up, we get 0. That's a terrible 0, and it is a neutral atom, we say, right? Let's now add our electron. We're going to add 1 electron, because that's all we need to get the full outer shell. Plus 9, 2, 8. Number of protons stays the same. That is 9 positives. Number of electrons is now 10 negatives. The charge on this, well, they cancel each other out. We could just add it up using our algebra or our integers. 9 plus 10 negative, -1. And so this is an anion. This is an anion. It is now an anion. We call it a fluoride ion because the negative ions get an IDE ending. Okay? That sound familiar to you from the past, perhaps? Grade 10, we would have done some things like that. So when you gain electrons, you have an IDE ending. You have a fluoride ion. Again, I really have no idea where everyone is. I see people already making charts way at the back. That's awesome. But it does make it tricky for me to know when to go ahead. Let me know if I'm needing to back up. So, some Lewis symbols. Oh, yep, that's okay. That's good. That's what I need you to do. I need you to tell me. Because, again, I look around and it's hard to tell who's writing what and where and when. See, and those of you who are drawing ahead, that's fine, but I like to draw it for you so that you can see the way the picture develops. Sometimes on a slide, it just jumps in front of you. You don't know how it's been done, right? It does, but all right, okay. We're good to go? Okay. So let's talk about Lewis diagrams. Remember Lewis diagrams? We deal with the dots. So I'm going to start with our F. How many dots go around my F? Yep. 7. 1, 2, 3, 4, 5, 6, 7. That's going to hopefully tell you that we need to gain 1 electron. So we're going to, again, add 1 electron. And that's now going to get me 1, 2, 3, 4, 5, 6, 7, 8. Again, because it is a Lewis diagram and it's charged, we must have square brackets around it, -1, and then the charge goes outside. Okay? All right? And again, that is a fluoride ion. So, fluoride ion. Terrible. What a messy thing that is. You get the idea. And its charge is -1. Okay? Let me do another example for you. Let's now move our way across. Let's do a phosphorus. Let's start with phosphorus. P. How many dots? Yep. 5. 1, 2, 3, 4, 5. Or you could have started with the 2, right? 2, 1, 1, 1. How many electrons do we need to gain in this case to get a full outer shell? Yep. 3. We need to add 3 electrons. Phosphorus. Now all those electrons are paired up. Excellent. It's got that full outer shell configuration. What charge does this become when we gain 3? Yep, Conrad? -3. -3. And what's the name of this ion, do you think? Yep. We don't say the oride. It's just phosphide. Phosphide ion. And that's tricky to know. Sometimes we get rid of some of the letters and sometimes we don't. It's phosphide. It's a phosphide ion. All right, excellent. Now at this point, I would then have you go through the sheet online and you'd finish it out and take a bit. But that's really, again, overkill. So now what we're going to do is you can, again, make a grid if you'd like. I'm going to give you another piece of paper, or you could just draw your lines like that, and you can finish that. You can work that. What's that? Yeah, I'm going to hand out the paper if you want. Let me stop the recording here, and then we can just go from there. Actually, I might just pause the recording. Yes, I'll get that stuff handed out. So I'm just, all right. So I just want to do it quickly. How many dots around my H for my Lewis of my ion here for this guy? Yep. 2. Special case. Square brackets. What's the charge? Negative. No. How many did we gain? -1. This is He, and this is a hydride ion. Excellent. How many dots around my carbon ion? Which really isn't called a carbon ion. After it's an ion, how many dots? 8. 1, 2, 3, 4, 5, 6, 7, 8. Actually, I'll put the number that are gained. -4. What's it isoelectronic to? Neon, right? We've moved ahead there. Neon, and this is carbide ion. Excellent. Silicon is the same. 4 Si, again, 8 dots. It's gained 4, -4. It's going to be, silicon is going to be argon, and this is a silicide ion. That's a silly name is what that is. All right, see how I did that? Silicide, silly name? All right. Nitrogen, how many electrons are we going to gain for nitrogen? How many electrons are gaining for nitrogen? Jessica? 3. 3, and that's going to give us a full outer shell, -3. That should bring us to neon, I believe. And what do we call this guy? Nitride. The nitride ion. Phosphorus is going to be the same. It's going to be -3. I just want to keep moving for time's sake. That's going to be a phosphide ion. Oh, how many electrons are we going to have to add to an oxygen atom? Jess? 2. Oh, now that it's got all its electrons, its full outer shell, what's the charge going to be on an oxide ion, Felicia? -2. Excellent, -2. Matching noble gas, again, is neon, and this is an oxide ion, and you've all heard of that before. Sulfur will be very similar. What's the name of the sulfur ion going to be called? Yeah, Shay? Sulfide ion. Sulfide ion. Excellent. We've already seen fluorine, so we will do chlorine to finish this one off. How many electrons does chlorine need to get a full outer shell? Yep. 1 Cl, 1, 2, 3, 4, 5, 6, 7, 8, because it's gained the charge. -1. It's going to be isoe electronic to argon, I believe, next one beside it. And what's this ion going to be called? Yep. Chloride ion. Chloride ion. Chloride ion. Nice. Let's look at the summary. And so I do need you to write this down. I want you to write down this summary. Oh, the helium ones, sorry, the noble gases aren't very excited. If you do not have this on your ion sheet, don't worry about it, because it really doesn't tell us anything. Yep. Well, it is the noble gas. I guess you'd write what it is, right? So let's say we had neon. It has 8 electrons in the outer shell. It's not going to gain any. It's Lewis, there is no, you'd say almost Na, or you could write the same thing. It doesn't form an ion, so there isn't any. Matching noble gas, it is itself a noble gas, and the name of the ion, it isn't an ion. They don't form ions, which I guess maybe that's why we kind of put them in there, all right? So again, if you don't have that on your sheet, don't stress about it, because they don't form ions. But the summary is quite important. And now what we're doing here is, and this is, I guess, kind of important, this last question down in here about what the charges are. And this puts everything together as we move across the table. So this can either go back into your note, or that can go on the bottom of your ions sheet. I don't care where you put it. What types of elements form anions? Yep. Non-metals. Non-metals. And now we're working our way across the periodic table to get the charges, including the positive ions. Because I need you to be able to look at what group is on the periodic table and think about what charge the ion becomes. So I'm going to let you have a chance to write that little block down somewhere, and then we will fill it in. We just did groups 14, 15, 16, 17, and we kind of did 18. We'll talk about that. But let's go back and review like we did at the beginning of class. Group 1, what charge do these ions become? Group 1, what's the charge on these guys? +1. They're losing electrons. The losers are over here. Metals are losers. So you can think of it that way. So, +1, because they lose an electron. +1. Group 2. Are these gainers or losers? They're losers. So what charge will this group 2 ions become? +2, because they're losing electrons. +2. Again, group 3. Yes, we do have the stair-step line, but the predominant group of them are metals. So are these gainers or losers? They're losers. So aluminum, what charge does it become? Yep, +3. +3. Now we're to our group 4, or 14. What charge are these guys going to become? -4. They can actually sometimes be losers as well. So some of them can lose. So I'm going to put here +/-4. You see what I'm indicating there? See how I'm doing that? The guys at the bottom are losers, and the guys at the top are gainers. Group 15, we're not going to worry about this guy way down here, or these two guys down here. What charge are these guys going to become? Well, are we gainers or losers at this point? Gainers. How many are we gaining? 3. So what charge is this? -3. All right? We're not going to worry about those guys. The majority of them, these guys actually, they can be +5, but again, the chemistry is complicated on why that is. 16, well, look at the trend here, folks. 1, +1, +2, +3, ±4, -3. 16, what's it going to be? -2. 17, -1. 0, doesn't form ions. Okay?